In order to determine what type of atom you have to know the proton number for that atom. So what I'm saying is that the amount of protons in an atom will determine the type of atom that atom is. So let's take a look at some examples and use these keys as indicators to what the subatomic particles are. We know that the atom has protons, possibly neutrons, and electrons. All right? The protons are this black plus positive symbol. The neutrons is represented by this solid blue circle, and the electrons are represented as circles with a negative sign in the center. Now, most of these things I'm going to draw is not really up to scale because these two are very massive and this is very small, but I don't have enough real estate space on the board. So let's get down to it. Let's look at the hydrogen atom. If we find the hydrogen atom in the periodic table, we can determine that hydrogen is 1. The atomic number for hydrogen is 1. That means it has 1 proton. What about the number of neutrons that hydrogen has? Well, if we look at the mass of this hydrogen here, and if the mass of the hydrogen is 1, that means that single 1 proton that makes up hydrogen makes up the entire mass of hydrogen. So that means hydrogen has no neutrons. Okay? So this is how we're going to draw. If we were asked to draw this atomic structure of hydrogen, we would say that there's just that one lone single proton. All right? There's no neutrons. We have determined that using simple math. What about the electrons? How many electrons does it have? Well, atoms now have the equal number of protons, and electrons. So that means this hydrogen here will have 1 electron. Okay? This dashed circles represents a concept that you learn in another time. Let's look at this thing. What could this element be? Well, in order to determine if it's an atom, what atom it is, we need to see whether we need to count the number of protons it has. Here I have 1 and 2. I have 2 protons, 1 and 2. So that means when we count the number of protons, look it up in the periodic table for the atomic number or the proton number, it ends up being helium. Helium has 2 protons. All right? And so there it is, 2 protons. And we can immediately write helium without any reference to anything else. But is this a helium atom or helium ion or helium isotope? Well, we can't really determine the isotope because it varies, but we can determine if this is an atom or we can't determine the isotopes because you need like 2 or more of the same kind of atom to determine if these 2 are isotopes. But just looking at this by itself, you can only make comparisons to see whether it's an atom or an ion. Because the number of electrons is equal to the number of protons, this means that this guy here is an atom. Let's look at boron. What makes a boron? Well, any boron atom will have 5 protons. All right? So what we do here is that we are going to draw the protons in. And if you notice the way I drew the protons in, it's quite spacious and random in general. And the reason being is that I'm trying to put neutrons in between the number of protons. So how much neutrons do I have in boron? For this boron that we have in our periodic table in class, we can see that the mass number is 11. So the mass number minus the atomic number will give me the amount of neutrons I have. So 11 minus 5 is 6. So I have 6 neutrons in the nucleus. So 4, probably draw another one, 5 somewhere, and another random one, 6 somewhere. All right? Now this is not exactly this fixed position in nature, in Mother Nature, but I'm just making a guess. All right? And how many electrons do we have? Well, the number of electrons should equal the number of protons. So boron will also have 5 electrons. Boron will also have 5 electrons. So 1 electron, 2 electron. And you notice that I'm drawing another dash circle at the outside. And the reason being is due to a concept that you will learn a little later on. All right? And that's boron. All right? But what you need to focus on is the number of protons in those elements or atoms. Okay? So what is this element? Well, to determine what atom it is, or element it is, or ion it is, we need to count the number of protons. 1, 2, 3, 4, 5, 6, 7, 8. 8 protons. So that means that atom is oxygen. Is it an atom? Well, if it's an atom, it should also have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so this is an atom. And what atom it is? It is oxygen. All right? Okay, so I hope I've clarified to you a little bit about how the amount of protons you have determines the type of atoms you have. And if we are to change the proton numbers, then you are basically changing the substance of the atom. You're basically changing the type of atom you have. All right?